In this video, we are going to be exploring the concept of energy. The definition of energy is the property of matter in which is manifested as the capacity to perform work. When it comes to chemistry, the ability to do work causes motion or interaction of molecules. Now, there are different types of energy out there, and as you can see, they are illustrated by the image that we have on this slide. But what we're going to be focused are on the main 4 types of energy that we will be dealing with in this course, which include potential energy, kinetic energy, chemical energy, and lastly, thermal energy. Let's now go over their definitions. When it comes to potential energy, this is the energy that is stored in a substance. And understand that potential energy depends on position. Kinetic energy is the energy that results from movement. If a particular energy is stored specifically in a chemical bond, that is called chemical energy. And lastly, thermal energy is going to be known as the heat, and this heat can be produced or it can be absorbed. When it comes to energy, there are different units utilized to describe energy. The most common units that are utilized for describing energy are going to be joules or calories. Understand that we can add prefixes to these units to make them larger. That's why we have kilojoules or kilocalories. When it comes to calories, understand that we can actually relate that to water. The reason is because calories specifically are defined as the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. So understand that calories and joules are related to one another by the following conversion factor. In this conversion factor, write it in your notes. For the exam, because it's not going to be provided. In the next concept, or in the next section of this chapter, we're going to talk about energy and nutrition. Because it is really important for those students that are in allied health or in general in your life to understand how energy is related to the things that we eat. Or it is generated or spent from processing certain biomolecules through the body. So I want to give you one example. 1 hour of swimming utilizes 2,100 kilojoules, or in other words, 502,000 energy calories or 502 kilocalories. As you might have heard, swimming is a really good exercise because you burn a lot of calories, but it's really easy on the joints too. Now, we are going to focus the rest of the chapter on energy and nutrition, specifically looking at how the calories that can be calculated in a particular food are generated by looking at certain biomolecules. To start that discussion, we need to be looking at the instrument that it is utilized in order to do this. So a calorimeter is used to measure heat transfer. So understand that in a calorimeter, it consists of a steel container that is filled with oxygen and measured in a measured water amount. Now understand that if you have a food sample in a calorimeter, and remember, calorimeters are utilized in the food industry to determine the nutritional calories in food. If you have a food calorie inside your vessel, you are going to have, as you can see, this is called the combustion chamber because your food will be combined with O2 to produce CO2, water, and energy. And that energy can be calculated. How is it going to be calculated? Once your food undergoes this reaction, which is called a combustion reaction, what is going to happen overall is that heat is going to be generated at the still combustion chamber. And see that you have a thermometer. The thermometer is actually going to measure the temperature difference of the water once the combustion has occurred. And through mathematical equations, you can actually back calculate how much energy is produced from a food. Okay? Now, let's actually look at that in the context of nutritional facts labels or nutritional labels. So, understand that on food labels, energy is shown as the nutritional calories, okay? And nutritional calories are written with a capital C. In countries like the United States, understand that we use nutritional calories, but there are other countries that utilize kilojoules to represent the energy in food, okay? So a nutritional calorie, notice that there's a capital C, it is related to the energy calories by the following equalities. 1 nutritional calorie equals 1,000 energy calories, and 1 nutritional calorie, therefore, is equal to 1 kilocalorie. It is very important to know that when that food undergoes combustion, the components of the food that specifically undergo the combustion reaction are highlighted here in these red boxes. So, the components of the food that actually undergo the combustion reaction are fat, carbohydrate, and protein. So even though your food will have other components, only those 3 are the ones that are part of the combustion reaction, creating that CO2, water, and energy. So whenever you're giving a nutrition facts label or a nutritional label, understand that you're going to look at how much fat is per serving and how much carbohydrate and how much protein to then double check if the nutritional calories that are given is correct, or sometimes it can be off. So you can actually compare it. How do I know how much energy each of these biomolecules contribute? Well, you look at table 3.7 in your textbook, and specifically you will be required to know the values in terms of kilocalories because they're related to nutritional calories. Remember, 1 nutritional calorie equals 1 kilocalorie. So that's how we know. This will be, the kilocalories per gram is the same thing as saying nutritional calories per gram. Same thing. So understand that carbohydrates, when they are biochemically processed, they contribute 4 nutritional calories per gram or 4 kilocalories. Fat contribute 9 kilocalories or nutritional calories per gram, and protein contributes 4 kilocalories or nutritional calories per gram. So let's actually go through the example of finding out if this food label calculated correctly the calories found in the serving for this particular food. As you can see, these are snack crackers. So we're going to make a list. And again, the bio components that we're looking at are the fat, the carbohydrate, which I'm just going to put the carbs. So carbohydrate, I'm going to simplify it as writing carbs. And lastly, we're going to look at the protein. And we're going to write the amount that we have on each per serving in this food. So as you can see, we have 4 grams of fat, we have 19 grams of carbohydrate, and we have 2 grams of protein. So we're going to use the values in the bottom, okay, that correspond to each of these biomolecules. So for fat, we know that it is 9 kilocalories in 1 gram. For carbs is 4 kilocalories in 1 gram. For protein, it is 4 kilocalories in 1 gram. So we're going to multiply these values. So in the first one, 9 times 4, that's 36 kilocalories that is contributed from the fat. Specifically, carbs is contributing 76 kilocalories. And lastly, protein is contributing 8 kilocalories. Okay? So in the last step of this, we're going to add these 3 numbers. And when you add 36, 76, and 8, you will see that the value is 120. And that is the kcals present, or 120 nutritional calories. And as you can see, that number that I obtained matches the one in the label. So that's how the nutritional calories in the label are calculated. Now, if we look at an example, and the one that I have in the worksheet in part D, this is an actual nutrition facts label for graham crackers, okay? Specifically for 2 graham crackers. Let's do the same calculation, okay? To determine if indeed we get 130. So we make our list. This serving of 2 whole graham crackers in terms of fat, carbs, and protein have the following. In this food product, we have 3.5 grams of fat. We have 24 grams of carbohydrate, and we have 2 grams of protein. So we add the amount of energy that each one of these biomolecules contain. Fat contains 9 kilocalories per gram. Carbs contain 4 kilocalories per gram. And lastly, protein contains 4 kilocalories in 1 gram. So when we do this math, we will do 3.5 times 9. So we obtain 31.5. Then we do 24 times 4. That is 96. And lastly, 2 times 4, that's 8. And again, the units here is kilocalories or nutritional calories because they are the same. Then we add these 3 amounts. So when you add 31.5 to 96 plus 8, you notice that the total is 135.5 kilocalories. In other words, 135.5 nutritional calories. So understand that these food labels in the US, they're actually not regulated. So whatever number the food company decides to do, it has to be close to this one that is calculated. And as you can see, they actually put a number that is lower. So as you can see, we have several questions that we need to answer when it comes to part D in the worksheet. The first one is, what is the serving size in grams listed on the label? And as you can see, that is 31 grams. And you can find it right here. How many calories are in one whole graham cracker? So we're going to take 135.5 nutritional calories, and we're going to divide this value by 2. And when we do that, we find that this is 67.75 nutritional calories. If you eat 3 graham crackers, then you're going to take that 67.75 calories, and you're going to multiply it times 3. That means that we get 203.25 nutritional calories. And if we look at the main source of calories of energy in this cracker, all we have to do is compare specifically 35 to 96 to 8. And as you can see, carbs, carbohydrates are going to be the main source of energy because it has the larger value out of the 3.